Hello everybody, getting ready to do lesson 5.3 part 3 today of pre-calculus math. If you need course materials or you need to contact me, email me here, animatedpowerpointmathvideo@aol.com. Today, part 3, 5.3, you got 4 points here to go into your notebook and 64 points here that goes into your classwork sheet. Starting with your notebook, functions involving multiple angles. The next two examples involve trigonometric functions of multiple angles of the forms sine Ku and cosine Ku. To solve equations of these forms, first solve the equation for Ku, then divide your result by K. An example of that, functions of multiple angles, solving 2 cosine 3t minus 1 equals 0. So here's the original equation. Add 1 to each side. So we're going to move this over here. Isolate our 2 cosine 3t over here. Then divide through by 2. So now we got cosine 3t equals 2. Moving onward with this. In the interval 0 to 2 pi, you know that 3t equals pi over 3 and 3t equals 5 pi over 3 are the only solutions. So in general, you have 3t equals pi over 3 plus 2n pi, and 3t equals 5 pi over 3 plus 2n pi. Dividing this result by 3, you obtain a general solution now of pi over 9 plus 2n pi over 3, and 5 pi over 9 plus 2n pi over 3. So knowing that, where n is an integer, this solution is confirmed graphically. So by graphing this thing here, you can see here where your solutions are here, and they would comply with your general solutions here. So let's try one now. Solve these multiple angle equations. Sine 2x equals the negative of square root of 3 over 2. So 2x equals 4 pi over 3. We know that sine equals the negative of square root of 3 over 2. So we just eliminate our sign, and we go 2x equals 4 pi over 3 plus 2n pi, or 2x equals 5 pi over 3 plus 2n pi. And then when you break that down, you can get x equals 2 pi over 3 plus n pi, or x equals 5 pi over 6 plus n pi. And then down here, for x, we just eliminate our secant x, because secant of 2 would equal 4x equals pi over 3 plus 2n pi, or 4x equals 5 pi over 3 plus 2n pi. And then when we break that down further, when we divide through by 4, we get x equals pi over 12 plus n pi over 2. For this one here, this 2 over 4 would be 2. And then for this one over here, we divide through by 4, we would get x equals 5 pi over 12 plus n pi over 2 for this one. So functions of multiple angles, we have 3 tan x over 2 plus 3 equals 0. So that is an original. So to solve this, we're going to subtract 3 from both sides. We're going to begin to isolate our tan over here. So then we divide through by 3. We have tan x over 2 equals negative 1. Then when we analyze that further, in the interval of 0 pi, you know that x over 2 equals 3 pi over 4 is the only solution. So in general, you have x over 2 equals 3 pi over 4 plus n pi here. So we solve for our first x equals 0 solution, and then we add an n pi to it, because in the interval 0 to pi, it's not 0 to 2 pi, it's 0 to pi. So multiplying this result by 2, you obtain the general solution of x equals 3 pi over 2 plus 2n pi would be our general solution for that, where n is an integer. This solution is confirmed graphically here, so when you graph this thing, this will all come to light here when you graph it. Y equals 3 times tan x over 2 plus 3 in this situation here. So when you graph it, that will be confirmed. So solving a multiple angle equation, we have cosine x over 2 equals square root of 2 over 2. Down here, tan x over 3 equals 1. So x over 2 would equal, in cosine, pi over 4 plus 2n pi, or x over 2 would equal 7 pi over 3 plus 2n pi. And then when you break these down further, you would have, when you multiply through by 2, you would have x equals pi over 2 plus 4n pi. And then over here, you would have x equals 7 pi over 2 plus 4n pi. And then down here, tan x over 3 equals 1. X over 3 will equal pi over 4 plus n pi. And then x would also equal 3 pi over 4 plus 3n pi when you multiply through by 3 here. So that would be the way that you would be able to plot that. 3 pi over 4 plus 3n pi. And that would be what your graphing strategy would be with that one. Using inverse functions now, solving secant squared x minus 2 tan x equals 4. So there's your original. So when you use your Pythagorean identities now, 1 plus tan squared x, which is the same thing as secant squared x, minus 2 tan x minus 4. And then we're going to combine like terms here now. So 1 plus 2 tan squared x. We have 2 tan x minus 2 tan x. So that would be tan squared x minus 2 tan x minus 3. So this would become over here, to get rid of this negative 4, it would become negative 3. And then we're going to factor this down now to tan x minus 3, tan x plus 1. Setting each factor equal to 0, so you're going to use your zero product property here. You obtain two solutions in an interval of negative pi over 2 to pi. Okay, moving in through our example here. Recall that the range of the inverse tangent function is negative pi over 2, pi over 2. So tan x equals 3 in this interval here, because this is open, this is closed here. And tan x equals negative 1. So in this case here, x equals arctan 3. And then in this case here, x equals arctan negative 1, which is the same thing as negative pi over 4 for arctan negative 1. Finally, because tan x has a period of pi, add multiples of pi to obtain x equals arctan 3 plus n pi, and x equals negative pi over 4 plus n pi here for your general solution for this trigonometric equation, where n is an integer. The solution is confirmed graphically here now. So here is your graph, and then these will be your x intercepts here at arctan 3 plus n pi, tan x equals 3. See, negative pi over 4 would be here, and then over here, this would be 3 plus n pi. So this would be negative pi over 4 plus n pi. So this would be pi over, this would be 3/4 pi over here, would be that intercept there. So let's try one now. In the interval 0 to 2 pi, tan squared x minus 6, tan x plus 5. So factoring this, we get tan x minus 1 multiplied by tan x minus 5 equals 0. So now we're going to solve each one of these for 0. Tan x minus 1 equals 0. Tan x equals 1. So in this situation here, x would equal pi over 4 and 5 pi over 4. And then over here, tan x equals 5. That would equal x equals arctan 5 would equal 1.37. And then x plus arctan 5 would equal 4.51 here. Pi plus arctan 5. Notebook. With some trigonometric equations, there is no reasonable way to find the solutions algebraically. In such cases, you can still use a graphing calculator to approximate solutions. So graphing calculators are really important in approximating solutions here. Approximate solutions of x equals 2 sine x in the interval of negative pi and pi. So use a graphing calculator to graph y equals x minus 2 sine x in the interval negative pi and pi. So y equals x minus 2 sine x here. So we move this one over here. And then when we graph that, we have this situation here. Here's a 0 here. And then it goes through the origin and then over here. Or the root feature. You can see that the solutions are x equals negative 1.8955, or x equals 0, and then x would equal 1.8955. So these would be the graphs here when you're using zeros here, when you're using your trace, and then you hit your root feature, you can find your solutions here graphically. Another 0 is over here, then a 0 is there. So let's try one now, and keep your graphing calculator ready. 3 tan squared x plus 5 tan x minus 4 within this interval here of negative pi over 2, pi over 2. So when you use your graphing calculator, you should have x equals negative 1.154 and then 0.534 using your trace feature, and then down here cosine squared x minus 2 cosine x minus 1 in the interval of 0 pi. You should come up with 1.998 for that one. On to our next example here. Example 12, surface area of a honeycomb. Surface area of a honeycomb is given by this equation here. Surface area here, this thing here. 0 less than theta less than 90 degrees or equal to 90 degrees, where h is 2.4 inches. So this is your height here, equals 2.4. Your surface, your s, in this case they call s would be a side here, would be 0.75 inch, and theta is the angle in this figure here, which it looks like it's between the center. There's a center line that goes up into here to a side of the bottom end of a cell, of a honeycomb cell. What value of theta gives a surface area of 12 square inches? So 12 square inches, where h is 2.4. So what do we put our s in that situation here? So here's our original equation. So we make it equal to 12. So which value of h gives a surface area of 12 square? We plug in 12 over here. And see, 2.4, we're going to plug in these values here into our formula here. And we're going to crank that out. And we have 12 equals 10.8 plus 0. This comes to 0.84375. Square root of 3 minus cosine theta over sine theta. And then when we elaborate that out, we crank that out, we come up with this consideration here. Using a graphing calculator set in degree mode, you can graph the function. So when you graph this thing, y equals 0.84375 multiplied by square root of 3 minus cosine x over sine x minus 1.2, and you get this. This is a 0 here for this number here, 59.86188. Using the 0 root, you can determine that theta in this situation, they say, is approximately 49.9 degrees. Will be your theta here. And theta would equal 59.9. So you have a 0 here at 49.9, and then a 0 over here at 59.9. So now, for that area there, so what value theta gives the minimum surface area? From part A at h equals 2.4, s equals 0.75. To obtain this, here is our formula there. And then graph this function using graphing utility set in degree mode. Use the minimum feature to approximate the minimum point on the graph, which occurs at theta equals 54.7. So this would be your minimum here on that function to find a min. So your area here varies with the angle of the closing in of a honeycomb cell. So the min here, the minimum amount of area would be here for a cell in a honeycomb. So let's try another max-min situation here. Graphing calculator. So we have, what are we finding the min of here? Of f or among its solutions. So we just want to find the min here of this situation here. Sine x plus cosine x. And then cosine x minus sine x equals 0. So we have two functions here. Using a graphing utility to graph the function, approximate the max and min points to 4 decimal places of the graph in the interval 0 to pi, which over here would be 0 to pi. And B, solve the trigonometric equation and verify that the x-coordinates of the max and the min points of f are among its solutions. So, okay. So to do this, first, here is your equation here of sine x plus cosine x. The min here would be when x equals 3.927, y would equal negative 1.412. And then your max here, which would be over here. Okay, so B, part B of this problem, solve the trigonometric equation and verify the x-coordinates of the max and min points of f are among its solutions. The trigonometric equation is found using calculus. So finding max and mins, as you would use within calculus, you would use derivatives to do that. Here we're going to solve it using a graph in calculator. So cosine x minus sine x would equal 0. Cosine x equals sine x. 1 would equal sine x over cosine x here. Tan x equals 1. So this would be the same thing here as sine x over cosine x would equal tan x in this situation. So x would equal pi over 4 plus 2m pi, and then 5 pi over 4 plus 2m pi. Those would be your solutions here. Pi over 4 plus 2n pi, so that would be pi over 4, and then this would be over here. This would be 5 pi over 4 here is where that would be, because that would be 2 times 0 pi plus 5 pi over 4. This would be pi over 4 plus 2 0 pi would be here. So that would be within between 0 and 2 pi. This is where your function here would cross your x-axis. And then the zeros are, they say here, 0.7854 and then 3.9270. And that is your 5.3 part 3 lesson. Email me here for questions, homework sheets, classwork sheets, and any other course materials. Thank you very much.